Right, in this video, we're going to review how to write equations from some word problems, and they're going to deal with linear equations and inequalities, and we're going to build our way into writing a linear system. And so let's look here at this first problem on the left-hand side. So Jilly's trying to make some extra money on her summer vacation. She's working two different jobs, $11 per hour washing cars, $13 per hour clearing tables. So I'm just going to highlight here. So the $11 washing cars and $13 per hour clearing tables. So how much money would Jilly earn in a week where she worked 3 hours washing cars and 7 hours clearing tables? Well, so she gets $13 per hour clearing tables. So we'd have 13 times 7. And we would add to that the $11 per hour that she gets washing cars, and she does that for 3 hours. And then we would just evaluate that to get our answer. So 11 times 3 is 33, and 13 times 7 is 91. And we add those together, and we get $124. Now, how could I rewrite this to determine how much money Jilly would earn in a week where she worked X hours washing cars and 9 hours washing tables, or clearing tables, sorry. Well, the amount of money she would make, just call it M, is going to equal, well, if X is the number of hours washing cars, that would be, she gets $11 per hour washing cars, so 11X, plus, and Y hours clearing tables, so she gets $13 per hour of clearing tables times Y. Casey's a high school basketball player. How many points would Casey score in a game if she made 2 free throws and 5 3-point shots? Well, a free throw, F, is equal to 1 point. And a 3-pointer is going to be equal, well, 3 points there. So let's just let J be 3 points. All right, so she makes 2 free throws. So it'll be 2 times the 1 point plus 5 3-pointers. And so we got 2 plus 15 and 17 points in total. Now, down here at the bottom, how many points would Casey score in a game if she made X free throws and Y 3-pointers? All right, well, I just need to change up my variables to account for this. So we're going to say P, the number of points Casey scores in a game. Now, X is my free throws, so it would be 1 point for every 1 free throw. So 1 times X plus 3 points for every Y 3-pointer. And so we can say just P is equal to X plus 3 times Y. Right here, a furniture store sells chairs for $150 each. All right, so each chair is $150, and tables for $400 each. The store must sell a minimum of $5,000 worth of tables and chairs each day. We want to write an inequality to represent the possible values for the number of tables sold, T, the number of chairs sold, C, that would satisfy the constraint. All right, well, each chair, C, costs $150. So the amount of revenue that the company would bring in for selling chairs would be 150 times C. The amount of revenue they would bring in for the total number of tables sold would be $400 per table sold, so we say plus 400T. Now, we want to sell a minimum of $5,000 worth of stuff, so that means that 150C plus 400T must be greater than or equal to 5,000. There's our inequality. All right, let's look at another one. Max and his kids went into the store to buy apples and bananas. Each apple cost $2 and each banana cost 80 cents. Max has a total of $20 to spend on his apples and bananas. We're going to write an inequality here that represents the number of apples purchased and the number of bananas purchased be? Well, so Max has a grand total of $20. So $20 has to be what it has to be the most amount that could be spent. So whatever I have on the other side of this inequality equation has to be less than or equal to $20. So each apple is $2. So we'll say 2 times A plus each banana is 80 cents. So we'll say 0.8 times B. Okay, now we're going to look at a system of equations in context. So we're not going to solve, we're just going to write the system. All right, here we have Mo and Larry both work at dry cleaners ironing shirts. Mo can iron 25 shirts per hour. Larry can iron 30 shirts per hour. And they also tell me that Larry worked twice as many hours as Mo, and they ironed 340 shirts in between them. All right, well, one of the first things you want to do is you want to define your variable. So I'm going to let M be the number of hours that Mo worked, and I'm going to let L be the number of hours Larry worked. All right, so now we're ready to start writing our equations. And so we're looking here, and one of the first things that comes to my mind is that Larry worked twice as many hours as Mo did. So we're going to write that as an expression. So L is going to equal 2 times M. And the second equation that we would have here, let me change colors on my highlighter, we'll go with orange, is, let's see, Mo irons 25 shirts per hour Mo works, and Larry irons 30 shirts per hour that Larry works, and together they iron 340 shirts. So we're going to put that as an equation, which would take us to, so 25M for the 25 shirts per hour Mo worked, plus the 30 shirts that Larry did while he worked per hour is equal to the 340 shirts they did total. Okay, last question. At a restaurant, each onion ring has 70 calories and each slider has 200 calories. All right, so I'm just going to underline here and make it easier to find. A combination meal with onion rings and sliders is shown to have a total of 1,020 calories. All right, so a combination meal, that means I have both onion rings and sliders. I have a total of 1,020 calories. And we have twice as many onion rings as sliders. Okay, well, before we start writing our system, let's first define our variable. So I'm going to use R, and I'm going to let R represent the number of onion rings, and I'm going to let S represent the number of sliders. So now we're ready to start writing our equation off of the situation we have here. So let's start with, let's try to relate R and S together. Now they tell us that this combination meal has twice as many onion rings as there are sliders. So I have twice the number of onion rings as there are sliders. So my onion rings is equal to 2 times S. Now we're going to relate the other part together, which represents the number of calories that we have. So each onion ring has 70 calories. Each slider has 200 calories. And when I combine them in this combination meal, we have a total of 1,020. So our second equation here, we would have 200 calories per slider, so 200S, plus we have 70 calories per onion ring, so 70R, is going to equal 1,020.